Hi everyone. In this particular video, I will explain you how we can implement limit without any library. So this is not the exact implementation of the limit, but this is an approximation. Okay, what do you mean approximation? So in the last lecture, we are discussing about, let's suppose we have a one function. Okay, and we are trying to find out the value of this function at particular point at x equal to 3. Let's suppose. Okay, just to make thing clear, just to make thing easy, I'm just taking x equal to 2. So on this number line, we are interested to find out the value of f of x at point 2. So how you can find out it? So basically, we are using the concept of approximation. So what do you mean by this thing? So we will go back to some point on this left hand side. So let's suppose this is a point at 1, and there will be point, let's suppose 3. So what basically we are trying to do here? So we are approaching toward 2, and we are trying to be very close to point 2 from left hand side. Same thing we are applying from the right hand side, and we will observe that whatever the value. Okay, so let's suppose the x value will be something 1.999, and from this side you will come, x value will be 2.00001, and we're trying to put this value into this function. Okay, so we'll get some answer. Okay, so that will be the approximate answer for that particular function at this point. That means what? This thing, if x will approach toward f of x, so we will get answer. So that is called approximation answer we are trying to find out. For an example, let's suppose, so we are starting from 1. So when we put 1 in that particular function, so we are not yet defined the function, but let's suppose we have some function, so we are getting some answer, and we are approaching towards 2, and we are getting some answer. So we are approaching from left hand side. So same thing we can approach. Okay, just a minute. We can approach from the right hand side also. So we are approaching from 3. So now at the end, if you observe, we are getting the same answer from the both. So it's not exactly same, but approximately you can think like it's the same answer. Okay, and then you can see this is we are approaching from the right hand side. So how we can implement this thing into Python? So that I'm going to explain in this particular video. Again, I'm clearing, this is not exact implementation of the limit. This is approximation of the limit. Okay, so let's implement it. So first we will import some library. Okay, so basically we need numpy. Okay, and then we need to define a function. Okay, so you can take any kind of function. So here I'm defining very simple function f of I'm giving the name of function is f(x), and then I'm passing the parameter, let's suppose, let me pass the value u, and here output equal to. So what I'm doing actually, so I'm just defining a function, nothing else. So this will be square of u -1, and then I'm just returning it ot. Okay, and now the next step will be we need to define the domain. Okay, or we can say that what will be the range. Okay, and in between we just need to define the range. Before the range, we need to also define that at what point, like for which point we want to find out the approximate value. Like in this case, like I was explaining you earlier, for an example, this is a x equal to, let's suppose, 2. So we are trying to approach towards 2 actually. So our point will be x equal to 2. So we are trying to find out the approximate value of this function when it approach toward point 2. Okay, so let's declare that variable. So I'm calling here one very okay, I'm calling a. Okay, and then we will define the limit range of value x, that is domain, and that I'm defining here as like that. NumPy array. So NumPy array, why I'm using it? Because I will use list or tuple. So we cannot do many operations, but if we have array, so we can perform most of the operation. I will show you, okay, in a minute. And then okay, so let's define it. So here I am writing a -1 and a +1. Okay, so I defined my domain. And then how many iteration we want actually. So like between 1 and 2. So iteration is like that. To reach 2, how many times, how many iteration you want actually. So that we can also define here. So I'm writing iteration equal to 10. Let's suppose 10 or 12, whatever you want, you can take it. Okay, so after iteration, so we want to track two things here. One is like value of x and other is the value of uh, function at that particular point. So we need to define two variable. Okay, so I'm writing x limit values. So this is I'm defining as a numpy array. So here I will say iteration. That means what we want 10 value of the size of 2. So I will just copy paste for like to store the value of limit. So limit vals. Okay, so now we defined it. Now what we will do, okay, so we will iterate it. Okay, so that means what, we will take one value from left and we will take one value from the right and we'll compute it, and then we will update the value of domain. That means we will update the value of x0 actually. So it's depend on you how you are updating it. So let me implement for I in, and then defining the range. So I will iterate till iterations, and then here what I will do, I will first take the x limit value, and then one. Okay, and then because x0 will contain two element. Okay, x0 is contain two elements, so I'm just storing it into x limit. Okay, so similarly I will paste for limit and all limit value and x limit. Okay, so what I'm doing here actually, so I'm storing the value of x limit, and then for each value of x I'm passing to f of x. So this f of x will give you two values, so that I'm storing into limit. So like why do two value, because one is storing x limit, other is storing value of limit actually. So after getting this one, we will update our domain. That means what, x0 will be x0 plus just a minute, okay, plus a, and we're taking the average of it. Okay, okay, so now this will give you the look that this line will update your x0 value actually. So now let's print it. Okay, so to save the time I will just paste the code over here. Basically I'm not doing anything, I'm just printing the value of x limit and limit value. Just a minute. So here what I'm doing actually, so I'm printing limit from left hand side, so you can see here. So basically x val contain two things. Okay, one is for left hand side, one is for right hand side. So if I'm putting 0, so I'm taking limit from the left hand side, similarly from the right hand side. So I will run it now. Okay, so there is one mistake, let me check it. Okay, just a minute, this should be comma. Okay, okay, there is not zeros, there is not zero, there is something called zeros. Okay, okay, so I'm taking another value because again we need to change it. I just copy paste, so that's reason we were not able to. Okay, now it's fixed. You can see now output. So limit from left hand side, if we are approaching from 1 and then we are going till 1.99, we are getting 2.99. Similarly, if we are approaching from 0.3, so we are reaching at 3.00. So now you can see that what will be the actual value at 2. So basically we try to approximate it. Now we will pass the value of value 2 and we will see that what we'll get as output. See, we're getting 3. So basically this is very close to the 3, 2.99 and 3.00. So I hope you understood the idea, like how limit is working. So basically if we are not able to find out the value of that function at particular point, okay, that is indeterminate format. So in that case, we are trying to find out the value of function by approaching to that particular point. Okay, so like we are approaching from left hand side and we are approaching from right hand side. Okay, so we are getting some value. Okay, so I hope you understood the code. Okay, so I will also post this code to the GitHub so you can access this code. You can play around this code. Okay, you can test with other ones, so you can change the function and you can do a lot of things with this code. Thank you so much for watching it. Bye bye.